Here we are in Unit 7.1. I'm going to do this in two parts. So part one, for estimation, we're going to talk about confidence intervals for the mean. Now, here's what estimation is. Estimation answers questions about the value of a particular parameter. So we might want to know, what is the value of the population mean? What is the value of the population proportion? Something like that. So let's start off here with a point estimate. Now, a point estimate for a parameter, like a point estimate for the mean, or the point estimate for a proportion, all right, that's just simply the value of the corresponding sample statistic. So for example, if a population has a mean mu, which is unknown to us because we don't know every value in the population, we can take a sample. And suppose we find out of that sample that x bar, the sample mean, is 6.3. Right, then the point estimate for mu would be 6.3. Now, we interpret this as being close to the value of mu. Now, point estimates are okay, but we can do better. You know, instead of a point estimate, what I'm going to do is I'm going to get an interval of values. All right, so now we're going to take a look at confidence intervals. So first of all, let's just talk a little bit about what they are. So a confidence interval, all right, that's a plausible range of values that will include some parameter a certain percentage of the time. For example, a 95% confidence interval is a range of values for which we are 95% confident contains the true mean of the population. Now, we'll draw a picture of this in a minute, but the confidence is not in the interval itself. If we repeated this sampling method many times and constructed a confidence interval each time, about 95% of those intervals would actually contain the true mean. So suppose there was 100 of us here in class, and each one of us takes a sample. We all get our sample means, so there's probably going to be 100 different sample means. We each go and apply this method, and we construct our own individual confidence intervals. So we come back, we've got 100 confidence intervals for the true mean. Now, if we're doing this at the 95% confidence level, about 95 of those 100 confidence intervals, those intervals, would actually contain the actual mean. 5 of us would miss it. Here's a picture. So suppose we have some population, and here's the true mean of the population. I'm just going to represent it like that. That's some number, you know, like 60 or something. Now suppose there's 100 of us. We all go out and we sample. We all take a sample of size, say 45. And from that sample, we compute the sample mean. And from the sample mean, we construct a confidence interval. Now, it could be that the first person's interval goes from that lower limit to this upper limit, and that person's interval would actually contain the true mean. The second person gets an interval, and that person's interval is like this. Right now, all the intervals are going to be a little bit different because we probably all get slightly different values for our sample mean. Third person comes out and just gets that interval. Well, that interval captures the mean. But suppose the fourth person gets this kind of an oddball sample and gets that confidence interval. Well, that interval does not capture the true mean, so that one would be off. Our estimation for the true mean would be off. And then, you know, the next person comes and gets that one. The next person comes and gets maybe this one. But then there's another oddball sample. Maybe we get this one, and then ... and then maybe, you know, you take the last one, you get this. All right, what we would say then is this. If we're running at 95% confidence intervals, how about CI? That would mean this. We expect, you know, about 95% of these intervals capture the true mean. So if there was 100 of us doing that, we would expect about 5 of us to miss it, right? About 95 of us would get an interval that actually captures the true mean and get good estimates. 5 of us would be off because we got unusual samples. But it doesn't have to be exactly 95 and 5. You know, it's just an approximation. So I just want to make an important note here. Got to be careful how we say it. It's a subtle difference. We are not 95% confident that the mean will lie in our interval. I don't want to say I'm 95% sure that the average cholesterol is in my interval. That makes it sound like the mean is bouncing around when actually it's not, right? The mean is fixed. What's bouncing around are our intervals, right? If you take an interval, you get one. If you take values, you get one interval. If I take a sample, I get another interval. So our intervals are the thing that's bouncing around, and we're saying 95% of the time our intervals will actually land on top of that true mean. So that'll finish our discussion of the part one of confidence intervals. In part two, we'll actually see how to construct a confidence interval.